Let's get it. Practice test chapter 5. Printout. Here we go. Is that it? Chapter 5 practice test. Again, should be roughly reviews, just all the stuff we've been talking about in chapter 5. I think that's large enough, right? Yeah. Find the reference angle for 3 pi over 4. So that's just pi minus 3 pi over 4. It's not shocking that that would be 4 pi over 4 minus 3 pi over 4, and the reference angle is pi over 4. Two is just asking you, have you been paying attention? Right? I got sine and cosine. The sine is the y coordinate. Okay, you want to say opposite over hypotenuse. That's good too. Okay. The sine is the y coordinate. The cosine is the x coordinate. What's the tangent?
Opposite over.
That's right. It's opposite over adjacent, or in terms of the circle, it's the y coordinate over the x coordinate, or it's the sine of t over the cosine of t. The tangent is all of those things. So if you're given sine and cosine, all of these just flat out come out, right? This question is simply testing whether you know the 6 trig functions. It's 4 over 3 in this case. The 5's cancel. Cosecant is 1 over sine, 5 over 4. Secant's 1 over cosine, 5 over 3. Everything's in the first quadrant. Cotangent is 3 over 4. So we'll start this test off super nicely, right? Questions there? It's all here. Determine the amplitude and period of the function. I'm sorry?
4. Amplitude 4, right?
Yeah, the amplitude is 4, that's right. Yeah, no, I was just like, wait, where come I hadn't even seen the function fully, right? Okay, so great. So I should be doing this one in my math lab. But we practiced this enough in the homework, right? How to graph this. Hopefully you've had enough practice. Let's get the formulas out one more time. So if I have A, the sine of bx minus c, right? And it doesn't even look like I'm asking about c. And we're saying that, go ahead.
If we have any questions, we go.
I don't think I can say yes to that at this moment. Yes. So, okay. So the amplitude is the absolute value of A. The period is 2 pi over b, right? And then the phase shift is c over b. So, yeah, so it's all there, right? So A in this case is -4. Oh, and this says cosine, they're the same, right? So A is -4, B in this case is 1/2, and C is 0. Yeah. So you can go ahead and fill all that stuff in.
Positive 4? If it's a...
No, A is -4, but the phase shift, the amplitude is going to be 4.
Oh, okay.
A, when you label, A is -4, the amplitude is the absolute value of that, right? The period is 2 pi over 1/2, which is 4 pi. And then you would graph it by simply putting in that information. Unit circle. Look on the circle. Sine of 3 pi over 4 is, oh yes, I hear pages turning. I see people looking it up. Sine is the y coordinate, 3 pi over 4 in the circle. Yeah, that's right, square root of 2 over 2. I'm sorry, I was dozing off. Square root of 2 over 2. Perfect. Look at the circle. Go to 3 pi over 4 in the circle. Find the y coordinate. Okay. Triangle definition. A is 5. C is 13. Remember what B is? 12. Just in case we don't remember. A squared plus B squared equals C squared. Last time we'll do it. 5 squared plus B squared equals 13 squared. 25 plus B squared equals 169. B squared equals 144. B is 12 or negative 12, but it's the side of a triangle. All right.
Excuse me, Professor.
Yeah.
Doesn't it normally show the little bar when you record it?
It does. I don't know why it's not, but it's going. It's going. Yeah, that something has happened that I must have accidentally pressed some setting that stopped doing that. Yeah, but it's recording. Yeah. The unknown side, B is 12, and we'll burn through these. Sine is the sine of B. This is in reference to B, so they're being annoying. So the sine of B is the opposite over 12 over 13. The cosine of B is adjacent over hypotenuse. Tangent is sine over cosine. Cosecant is 13 over 12. Secant, 13 over 5. Cotangent, 5 over 12. Anything down here? Nope. 3. Got a problem like this in the homework. Tangent to 3 pi over 4, just trying to test you. 3 pi over 4 is here. They tell you in the picture. -1. Right? So it's the y coordinate over the x coordinate. They're the same thing except for the sign. 23 pi over 4, it's going to end up being the same thing, roughly, right? 4 into 23 goes 5 whole times, right? Remainder 3. 23 pi over 4 is 5 pi plus 3 pi over 4. 2, 4, 5 pi, and another 3 pi over 4 takes you here. Tangent is the y coordinate over the x coordinate, and it's still the same thing. Questions about that? Counting around the circle? Seem to practice that pretty well. 7. Triangle. Looking for the angle. A telephone pole shown at the top of the next column is 60 feet tall. A guide wire 80 feet long is attached from the ground to the top of the pole. Find the angle between the two. That would be cosine. 60 over 80. Cosine of theta is, that's 20, right? 3 over 4. Theta is the inverse cosine of 3 over 4.
The 80's inside or outside?
Say it again?
The 80's inside or outside? It's inside, right?
What 80? The
Inside the picture.
Yeah, but it's still referencing the length of this.
Oh, okay.
Whether or not it's above the line. Yeah. Yeah. And round to the nearest whole degree. Right? So of course we're in degrees. We'll need just a little bit of space for this. There's a triangle at play here. This is one of the last problems we did last week.
We're gonna listen to calculator? No.
Oh, it might be nice. I think it's so here's the street version. If this turns out to be, so you can't put this in the calculator, right? So if it turns out to be a nice fraction, rational number, then it'll give you a decimal. Yeah, you can try it. It'll give you a decimal, and then if it's a fraction, then you can make it a fraction, and the fraction shows up, and you're good, right? If it involves square roots and stuff, then yeah, the calculator's not going to give it to you. Although some of these calculators will. That one might. I think that one does square roots pretty nicely. I don't know if that one might. Inverse sine, tangent. Does it give you?
It's -4 over 3.
This one?
That's what I know.
-4 over 3? Okay, excellent. Then it will tell you. This one turned out nice because there are no radicals. If the answer involves a radical, your TI won't tell you. If the answer involves just regular numbers, it'll give you a fraction, and then you make it it'll give you the decimal, then you can make it a fraction. Okay.
But how did you know it's supposed to be in degrees? Did it?
I don't know. Did I say it had to be in degrees? Not for this one.
Oh, I thought you said.
Oh, I don't think I did. That was one. I think the last one involved a triangle. Right. So,
Maybe my answer's wrong.
yeah. So.
Yeah, because mine was in degrees, so it might be wrong.
Okay. Let's see what we get.
Negative 43.
Negative 43. All right. So let's see how we would get that by hand, just in case you run across some radicals. All right, so then we've got, you let theta be inverse sine of negative 4/5, right? So then theta, the sine of theta is negative 4/5, right? And so then, I did not mean that. So then, oh, where did this thing go? I think it's here. Yeah, so then we've got a triangle that looks like this. Take away the sine for the moment. That looks like opposite over hypotenuse, right? So we need this side. And blank 4, 5? 3, 4, 5. That's the triangle. Here's the angle, and we're looking for the tangent. The tangent is opposite over adjacent, and we just have to remember that this angle is in the fourth quadrant. And so the tangent in the fourth quadrant is negative. So, but it seems like you've been saved by the calculator for this one too. So you can double check. Okay, so what page was that? That was page 3. All right, so that's good. So we just did that one. Page 4, convert degrees to radians. 195 degrees equals 195, and I need to multiply by, what is it? Pi over 180. 195 pi over 180. Calculator will help you do all the reducing you need to on this fraction. 195 over 180. Is it? We'll take your word for it. Yeah, 13 power over 12. Right. I guess it's 15, right? You have 15. Solve the right triangle. 27 is 27.1. C is 50.4. This is what we did today, right? I'm going to leave that to you to do for number 10. So all this stuff is 5.8. I'm going to leave the 5.8 stuff to you because that's stuff we've already done today.
You said 25 questions?
It is, yeah.
All right.
Y equals 5 sine of 1/2 x. Same old stuff.
Yeah.
13. What quadrant are we in? Tangent's positive, cosine is negative.
The second time? The second? No, fourth? I think it's the fourth. I think it's the fourth. I don't know. I forgot.
All right, here's the reasoning. What's the cosine?
X.
Yeah, cosine's the x. Got one person saying it, and it still took too long. Okay? Cosine's the x. And here's the deal. All right, so I should pause this, but I'm not going to. So the way that this works in academia, that we got way too much power. I could roll through and put F's on everybody's transcripts. right? You cannot walk out of this place without knowing that the sine is the y coordinate, the cosine is the x coordinate. I don't care if you ace every exam, you don't know anything about pre-calc unless you know that the log is the power, the sine is the cosine is the. Thank you, appreciate it. That's good. Okay, so here we're telling you that x is negative, right? So it would be nice if we knew what the y coordinate was, but they're telling us that the y over x is positive. So if x is negative, y over x is positive, tell me about y.
Negative.
Y has to, say it again?
Probably negative.
More than probably, brother. So y is negative. Both y and x are negative. What quadrant?
3.
Questions?
3.
Yeah. Right. So the only reason why I'm asking you that question is for us to continue to remember the definition. Right. So when we phrase this in terms of x's and y's, everybody sees it pretty quickly. Right. This is exactly what I'm asking you to do. Remember that the cosine's the x, the tangent the y over x, and once you know what x and y are, you can obviously pick the quadrant. It is 3. Good. Testing the bearing, you can answer that. Stuff from 5.8. All right, I'm gonna give you one trig function. I'm gonna tell you something else about the other one. I want you to find all the other ones, right? I know. Tons and tons of radicals all over the place. There's gotta be one that's tedious, right? Actually, I don't wanna bring this whole thing. I don't wanna copy this whole thing over. What page was that? Was it 6? Tangent is negative 24 over 7, so I just want this with all the space we're about to use. I just want that. Okay. So then we're talking about this. All right, so we can do this in a couple of ways. Okay, so say it again.
I think it's quadrant 2.
Think it's in quadrant 2. The cosine's negative, the tangent's negative. Is that quadrant 2? Right? Because the x coordinate is negative, but the y coordinate has to be positive if the ratio is negative. The y coordinate is positive, the x coordinate is negative. That's quadrant 4.
2, yeah.
I'm sorry, 2. I apologize. It's 2. Okay. So I'm debating which way to do this, right? So Julie, how do you do this? Do you use trig identities or do you create a triangle?
Won't we have to find the a squared plus b squared?
We could do that, yeah. So how did you all do this in the homework? How do you prefer to do this?
I forgot.
Okay, that's a good response. All right, so we could use some 1 plus tangent squared equals secant squared, right? I had another way to do it though, so I wanted to see which one you like better. All right, so you can do this, and then once you have secant, that would give you what? If you have secant,
Cosine.
that gives you cosine, right? And then once you have cosine, you can get sine, and then once you have sine and cosine, you can get all the rest of them, right? The other way to do it is to draw a triangle, right, and observe that if this is the angle, right, and then what's this side? And what's this side? 7. And then what's this? 724.
Some big numbers.
All right, so we'll find that in just a second. And you just do the stuff on this triangle. What is the only thing you need to take care of? The signs. You just need to make sure the signs are right. But we know the quadrant. So this might be okay, right? I think this is 25. 7 squared plus 24 squared equals z squared.
Actually, it was 25.
Is it?
Yeah.
49 plus 576 equals
625.
625. Z equals 25, okay? And so then we can run all of the stuff we know about sine, cosine, tangent for this, right? So then the cosine of theta is adjacent, 7 over 24, and we just need to make sure because we're in quadrant 2, I'm sorry, it is 25, thank you. It's negative 7 over 25, and it's negative because we're in quadrant 2. Sine would be 24 over 25. Is the sign right? Right? Quadrant 2 has to be positive, and then it's over, right? And then secant is 1 over cosine, 25 over 24. Cosecant is 1 over sine. I'm sorry.
Wait.
It's minus 25 over 7.
Yeah.
Thank you. Cosecant's 1 over sine is 25 over 24. And then cotangent, we have from the beginning actually, is negative 7 over 24, right? This way it's much easier, right?
Yeah.
Right. So create the triangle and just remember the quadrant. I rarely teach it this way, but it's much easier than doing all that identity stuff. Yeah. Questions about that? Six. Okay, so then word problem. That's that 16 that we already talked about. Find a positive angle less than 360 that's coterminal with minus 1,030 degrees. What do I have to do with it?
Keep adding 360.
Keep adding 360. 360. How many 360s do you think we need?
3.
We do need 3 of them. Okay. Minus 30 plus 1,080. 50 degrees. Okay. We need to know about whether sine is even or odd and cosine is even or odd. So 13, the cosine of negative t minus the cosine of t. The minus sign doesn't matter, right? 13 cosine of t minus the cosine of t is 12 the cosine of t. And they just wanted to call the cosine of t b, right? So this is just 12b. 12b. Okay. Go ahead.
Can you just subtract by 1? And then
Yeah, but the only remark is that the only thing I'm testing for this one is that you know that these two things are the same thing. Like it doesn't matter the minus sign at all. Okay. 7, we're plotting, right? So then you just need to get the amplitude, right? So again, the same formula as we were just doing. Okay, that's for 19. 21, tangent power of 6, you just do the y over x coordinate. I'll do 20 in just a second. So tangent of power of 6, go to power of 6, they give you this thing. It's 1/2 over the square root of 3 over 2. That's 1 over the square root of 3. We've done this so many times. Square root of 3 over 3. 20, got to get a triangle together. We need a nice way of writing this with square roots. 5.7.65 is a way of practicing this ad nauseum until you feel like you've got it down cold. Study plan, chapter 5, session 6. The cosine of this happens and comes up in Calc 2. So again, we do what we did before. Theta is the sine of 6x over 1. Got a triangle. There's theta. Opposite 6x, hypotenuse 1. We need to find that side, and then we can take the cosine of it. Z squared plus 6x squared equals 1 squared. Z squared equals 1 minus 36x squared. Z is equal to the square root of 1 minus 36x squared. I flew through that. Let me take any questions on that. Right, so Pythagorean theorem, that of course is a right angle. So z squared plus 6x squared equals 1 squared. We're solving for z. Now that we have the adjacent side, we can clearly take the cosine of the angle. The cosine of that angle then is the adjacent over the hypotenuse. I want you to put that in. Okay? Questions there? How bad does this get? That was 8. Let's see, 7. Okay, 8. We're almost there. Same thing, right? So 22 here is, we can put it here. 22 fine. So the point 8 negative 4 is a point on the terminal side of theta. So we need R. It is quadrant. What quadrant is it? Fourth quadrant, right? So R in this case is the square root of 8 squared plus negative 4 squared. I think we're going to go ahead and have to reduce some reducing here. That's 64 plus 16. That's the square root of 80. Now this becomes an issue of my math lab and about how much they want you to reduce, right? This has a 16 in it. 16 times 5. This is 4, the square root of 5. And we just have to rationalize a ton. Okay. The sign is going to be the y coordinate, negative 4 over 4 square root of 5. So it's just x over r. So this one's, I'm sorry, it's y over r, x over r. And then all the rest of them just follow. Y over x, r over y, r over x, and then x over y. Right?
How long we got to the exam? How long we got to take? An hour? Take the exam?
I don't think, so it's just open. I'm just gonna have it open.
Oh, so,
So I'm not even putting a time, no. I'm not even putting a time, yeah. Go ahead.
Is it? No, I guess that works.
What?
I was just thinking since there's a square root in the denominator, but it's not a square root by.
It is a square root. You're gonna have to rationalize.
Yeah.
Right, so this is negative 1 over the square root of 5, which is minus, how do you rationalize this? Square root of
Square root of 5
over 5.
Yeah.
so we got to do that?
Just making sure.
It wants this, yes, it wants this,
Wow.
yeah. So where is it? Rationalize all denominators. Cosine is the x coordinate, which is 8 over 4 square root of 5, which is 2 over the square root of 5, which turns out to be 2 square root of 5 over 5. Right. And then it's y over x, negative 1/2. Cosecant is what? Negative square root of 5. You could flip this one, but it's just flip that one instead. Secant is, flip this one, square root of 5 over 2. Cotangent is negative 2 over 1. It's just you flipping the tangent. S equals r theta. Find the radian measure of the central angle of a circle of radius 3 and an arc length 11. All right, what are they looking for in this formula? Is it S, R, or theta? Theta. Theta is S over R. Okay. 11 over 3. Okay, it's already in radians. These are so out of order and crazy. Sine of negative pi over 3 is just minus the sine of pi over 3. Or you can go backwards on the unit circle, right? Sine of pi over 3, you'll have the circle, right? Square root of 3 over 2. And then for the game, S equals r theta, except theta needs to be in the radians. All right, we're being bad. I've given it to you in degrees. Change it to radians and then use the formula. 120 degrees is equal to 120 degrees times pi over 180. Again, when you look at the circle, you'll see that this is just 2 pi over 3. Right. They want you to write this in terms of pi first, and then they want you to round. So S equals r theta. S equals, r in this case is 9 times 2 pi over 3. That actually reduces nicely. It's 3 times 2 pi is 6 pi, and then they just want you to round that to 2 decimal places.
So it is 6.
6 times 3.14, whatever. You could put 6 pi in there and round it. Right. Okay. So yeah, I think it's gonna be pretty straightforward. Yeah, and we'll burn through it. Again, you got a week to do it, over a week to do it. Yeah, we're good. Well, in there.
We got class Wednesday, right?
Yeah, we have class Wednesday. I'll be flying up here from Atlanta.
Or 100.
It's impossible to go 100 without killing somebody coming from there.
Go that far. Maybe like 15.